Okay, good afternoon, everyone. This afternoon, we are really fortunate to have a guest speaker with us and a really good friend of mine, Dr. Theo Dounas or Theo Dounas. Theo is an architect and an academic expert in design computation for architecture. His research focuses on decentralized production via blockchain, which you will hear a lot about this afternoon, generative and parametric systems with a tight orchestration between design and fabrication. He is currently directing what is called ArchiDAO. Was that part of it, or well, that's another one of it. But www.archchain.cc, if you'd like to take a look at what that is about, it's a project that seeks to establish a decentralized building information modeling toolset and mechanisms for the AEC industry. And I'm sure this is not all he has done in his life. He has built buildings. He's a registered architect. He has worked on all sorts of things in computation and has traveled the world. He was in China also before coming to Scotland. So with that, I will hand it over to Theo, who is going to direct this whole afternoon. And as you know, also tomorrow's workshop.
Okay, so we're going to set the scene computationally. We're going to set the scene in terms of political economy, and then we're going to take a look at projects we've done. I will try to keep it slow. So if you have any questions, you find something strange with, most probably in this talk, you might find some computational aspect strange. Raise your hand and ask me a question, right? If you're on Zoom and you're not here, just pop a question on the chat, and I'll try to answer the question. But certainly, I would like to end, I'm going to take something like an hour or an hour and 10 minutes to present the project, and then the rest of the hour we'll set up our environment and probably go through our first smart contract on a very easy basis. And then we can continue tomorrow, whomever wants to continue. Certainly, I've said to Wassim as well, anyone that wants to develop any projects on smart contract and wants advice, happy to help as well after the workshop, right? So I'm very, very open to collaboration and contacting. So personally, my kind of travel and adventure in computation starts with this guy, Alan Turing, who is a kind of hero of mine and the inventor of the conceptualization of what a computer is, right, with the Turing machine. And we'll see how this is very important. So that conceptualization is very important for blockchains, but also for the underlying technology that makes them worthwhile, which is cryptography. On top of that, you might find yourself somewhere between the Matrix and Alice in Wonderland when you talk about blockchains, because some of the distributed kind of ideas about computation are a bit strange. So try to keep an open mind, but at the same time, be as critical as possible. And the next slide kind of goes through that. And this refers essentially to one of my favorite novels as well, right? So that's Dune, that describes a planet that contains a very, very valuable spice, and is kind of like the center of the universe in terms of economic production. But also it describes a universe where computation by machines has been banned. Right? The novel describes a war between machine and machines, AIs and humans, and that humans have declared AIs illegal, right? And all computation needs comes from training humans to act as computers, right? They are calling them mentat. So the book kind of presents, if you will, a post-apocalyptic ecological kind of critique of computation as well. So if you haven't read it, do so. It's really a fascinating book. There was a movie also that came, another movie that came recently out. And in terms of architecture, I'm going to start with Ulysses or Odysseus, right? So I don't know if you know this, but there was a really fantastic poet 3,000 years ago in Greece, where I come from, where he wrote the Iliad, which is the story of the War of Troy. And then she also describes one of the heroes returning, essentially Ulysses, in the poem Odyssey. And kind of Ulysses is the kind of quintessential architect or engineer, right? So he's a person who is very inventive. He's very, the poet calls him polytropos. So he has very many ways to create stuff. So when he returns at home, because he's been away for 20 years, right? His wife, I mean, there's a whole story about him returning and kind of being king again, but his wife plays a test on him, right, and says, well, you know, the king has been away for so many years. Please take his bed out of the chamber and put it outside so he can sleep, you know, because I don't remember him so well. And that's a test because what Ulysses has done is, you know, he immediately reacts and says, that's impossible because I carved the bed. The bed inside that room has been carved out of an olive tree. So I took the olive tree, I didn't cut it, right? And as it is planted there, I shaped the bed, and around that, I shaped also the architecture of the chamber. And this acts as a kind of cryptographic sign, you know, embedded in architecture that Penelope, his wife, tests Ulysses with. But also it acts as a kind of simile for the way we are doing architecture now. We're taking natural resources and we're transforming them into architecture, right? So against that, I'll place another kind of idea, which is a little bit more, I would say, Asian, or an idea that we have kind of forgotten in the West. And it's from a philosopher called Byung-Chul Han. He's written a really nice booklet called Sanjai, Deconstruction in Chinese. And within that, so Sanjai is this kind of idea that the Chinese have of taking ideas that seem completely disparate and different and kind of remixing them into a kind of new thing, right? And one of the ways Byung-Chul Han explains this is by looking at the signatures, the jade seals of the scholars. And every Chinese scholar essentially has a jade seal with their name. And within Chinese culture, and we have some of you here that can verify this, the seal is the person and the person is the seal. There is no difference between the signature and the person. So he describes a really, really nice case of painting, of landscape painting, that is given as a gift to a set of scholars, to a scholar by his friends when he's about to leave. And everybody has written a couple of characters and a part of verses and poems and has signed it, right? And the collective signature piece is what they give out as a gift. So probably you've heard of non-fungible tokens, right? And these are essentially digital entities that with a unique digital signature, right? And a lot of people present them as unique features, but actually the Chinese did it first, right? By having this collective signature on a scroll. And I want you to kind of introduce the idea here that we might be able to do architecture not by taking natural resources and being extractive into our economy, but actually repurposing what is already there as architecture and changing it into something new, right? And this is the other idea we're going to explore today. And it's very close to, I mean, even without the computation, right? If you try to find this book, it's called Non-Extractive Architecture by a collective called Space Caviar. And this essentially does a critique of the whole discipline of architecture since kind of like the beginning of time in terms of its nature and how it has kind of led to the world we're in at the moment, with the trouble we already know we have in terms of environmental crisis, potential of climate change, and obviously issues of carbon impact, issues of waste, right, and changing nature in one direction. And in many cases, a lot of the work I do on smart contracts is inspired by this kind of critique of the discipline of architecture and how we could kind of create a new idea of designing without depletion. And we're going to explore essentially the relationships of architecture with economy, but also the relationship of governance, which I think is going to be really important for you because you might be developing tools, but what you also need to develop is a system of making decisions. And this is what governance is, right? So how do you actually make decisions in a project? How do you set up a project so that you have the best outcome possible? There's another, this critique of architecture is not new, right? There's been architects who are really famous for having critiqued architecture and its relationship with capitalism. Bernard Tschumi is one, right? A lot of the star architects of kind of like my generation, if you will, or people who are now star architects, started by being critics of the system, but at the same time they were like recognizing that if you want to do architecture, you cannot block the way the economy works. So you need to try something else, right? So Tschumi called it a tactic of judo, right? So using the forces of one's opponent against them. But at the same time, we are finding ourselves with building and construction accounting for 39% of all carbon emissions, whether this is through new buildings and constructing buildings, or whether this is through operating the current building stock we have. And that brings us to the potential essentially for using blockchain to try and solve part of what we're trying to do here. So what is a blockchain essentially, right? So let's kind of demystify certain things before we look into smart contracts and details of that. So blockchain is mainly a distributed computing network of equal nodes that all host the same decentralized ledger. If you want to understand what a ledger is, imagine that you have essentially a bank account with inputs and outputs, right? So when you add money to it, that's an input. When you you take money out of it, right? That's an output from that point of view. And the first blockchain was created by a group of people or one person, we don't know, with the alias Satoshi Nakamoto, publishing the Bitcoin paper in 2009. And we'll explain a little bit how they work in terms of their inner workings, right? The idea is that all nodes hold the same ledger, right? But immediately, and there is no hierarchy in terms of some nodes being more central than others, right? As you would have in a server-client kind of relationship. So immediately you have the problem of how do you coordinate the ledger between the nodes? How do you reach consensus of what is the truth, right? And the way to do that is you introduce essentially a cryptoeconomic, actually a cryptographic problem that some of the nodes attempt to solve. And if they solve it, they are elected to mine the next block, change the ledger. On the very, very, very basic structure, the data structure that exists on the blockchain is a block of transactions which are chained together with cryptographic hances, hence chain of block, blockchain. Every header, essentially, sorry, every block contains obviously the header. It contains a cryptographic hash. You all know what hashes are. Okay, we'll explain that a little bit later. But essentially, it is a way that cryptography has to take any amount of information of any length, let's say 256, I don't know, a whole novel, and reducing it into a particular specific size information length, right? So a 256 byte algorithm will reduce everything to 256, and it's a transaction. It's a transformation that happens only one way. So if you read a hash, you can't decipher what is the information that produced it. Okay. So the way this works is we have transactions taking place on the network, which is what you see on the bottom part, which are hashed in pairs, and this creates essentially a Merkle tree named by the cryptographer who invented it that ends up as a hash as a Merkle root. We have a number used only once, which runs in sequence, right? So you number the blocks 1, 2, 3, 4, and so on. You get a timestamp, and you also get the path of the previous block, which means that if you want to go back in time and change something on the blockchain, right? You have, first of all, to go find all of the nodes around the world that hold the ledger. But also, if you change, say, block 235 and you're in block 500, you need to change all of the other blocks in sequence that come after it. So practically, that makes it completely impossible to delete anything from the blockchain. So we have the first property that is kind of valuable to us, which is that blockchains are immutable. Okay. There is obviously an issue in terms of consensus, right? So how do you arrive essentially on to get elected to mine the next block, to create the next block? And this is the diagram that shows how Ethereum works in terms of its consensus algorithm. And essentially, you have below a competition where every node takes a number used only once, a nonce. The previous header runs it through SHA-3 algorithm, creates a 128 byte mix, and compares it with the pre-selected target. If it is a match, then your node gets elected to mine the next block and then propagate it throughout the blockchain. And if that happens, you are rewarded with cryptocurrency. Hence the idea of mining Bitcoin or mining ETH, right? This is the algorithm that runs on the Ethereum blockchain. So you have essentially a financial incentive to participate in a positive sense in the system. Now, after Bitcoin, a couple of people understood that if you have a ledger where you can do addition and subtraction, where obviously then you can do multiplication and division, and if you're doing mathematics, you can do computation. And if you can do computation, you can program it. So they were trying to introduce the idea that you could actually run software on Bitcoin essentially. And the Bitcoin people wouldn't have it. So what did they do in open source fashion? They created their own projects, right? Forking essentially the idea of a blockchain, and they created Ethereum. And Ethereum is essentially a state machine, right? So it's a blockchain which on top has a kind of global computer. And on its very basic level, it resembles a Turing machine where transactions will actually change the state of the virtual machine. And because it's a machine, you can run essentially software on it called smart contract. You can see a visualization of it here. So this is a combination of blocks and software essentially being committed to the blockchain part of Ethereum. It's Turing complete, which basically means that we don't know whether a computation will terminate. And this introduces, so we need an external trigger to terminate the computation. We need a rule that says if you reach that stage, then computation is terminated. Hence, we introduce the concept of gas, where gas pays for computation execution, right? So at the phase of an impossible computation, or at the phase of an infinite loop, the process will run out of gas. But also this acts as a security mechanism in the sense that any attacker trying to exploit a smart contract will have to have a lot of gas to actually be able to be successful. Okay. And we reached essentially the smart contracts, right? These are this is software essentially that executes on the Ethereum blockchain automatically. You can kind of conceptualize what a smart contract is if you think of an automated vending machine as software, right? So I put a token in and immediately I get something back. And they're not full programs, right? There are more classes of code that run on EVM. And from a programmatic perspective, even though they're called smart contracts, so it implies that there is some kind of legal authority onto them, right? The idea of the contract is that you are creating a digital protocol which facilitates, verify, and enforce the performance of a contract, essentially credible transactions without intermediaries or third-party guarantees. Okay, So the idea is that the contract will execute every time the same manner without needing someone to either a machine, a server, or a human to intervene. And you probably have heard of tokens or crypto tokens, right? Essentially, tokens are smart contracts, right? So non-fungible tokens, the NFTs, are essentially a kind of smart contract, and they create essentially economic utility. You can use it to capture part of value, but also you can use it for automation, as we will see in some of the projects. And I've put in the medallions here to kind of show the idea of the non-fungible token, which is a unique digital entity living on the blockchain, but also the game token, which is kind of the same idea we had in arcades. I don't know how many of you have lived through that kind of idea that you would go to a Luna Park, right, and you would change your pounds or dollars with game tokens that only are useful, right? They have economic utility only within the game arcade, right? And you can spend it and exchange it there. But between them, they're exchangeable, right? And as we were discussing, right, we're looking at an industry that is essentially fragmented, unproductive, and adversarial. I won't go too much into this, but on top of the other problems we have in terms of the industry being extractive, it is also not very productive, right? So if you compare it to, say, the aerospace industry, right, they've had an increase of production by about 40% the last 20 years. If you look at AEC, that's about 1%, right? And potentially you're part of the solution, essentially, right, to make the industry more efficient. So part of what you might be discussing, why would we use blockchain for AEC, right? It's an economic technology. It's a technology that was designed initially to replace banks, right? Satoshi Nakamoto wrote the Bitcoin paper saying, well, our central institutions, the banks, have failed in the US, right? Well, in other countries as well, Greece being one of them. And we needed some other computational perspective to kind of replace that. Well, it is, I think, really interesting to understand that you can run a whole organization on a blockchain, right? And this is what you might have heard this term, a DAO is, a decentralized autonomous organization. So that's one part of the answer. The other part that I think is a little bit more intuitive is that because the industry is so fragmented, right, to actually create any kind of project, you need to have a series of smaller players coming together for every project. Sorry, give me a second here because this thing jumped in the middle. Move it on top. Good. They come together for a project. We don't have vertical or really good integration between players, right? Every project is different. Every project is unique, and you have all these small SMEs that essentially have a really fragmented landscape. This is what you can see in this diagram, essentially, in terms of the lower part, where, well, actually, the number B is essentially more of a blockchain, and number A and C are the construction industry as a decentralized collaboration network. So from that point of view, it is a kind of good fit of a technology to organize work within AEC. And the three things that we care about within this kind of idea of using blockchain for AEC is incentive. How do we reward good practice? Or how do we punish practice that is or behavior that is not desirable? There is a shift of trust to the computer protocol. So we shift our trust to smart contracts compared to actually shifting trust to an institution. And it is, as we call it, with a kind of 2022 flavor, decentralized. There are no barriers to participation. Why am I saying it's a kind of shift in terms of the meaning of decentralized? Decentralization used to be this kind of part of architecture and urban planning in terms of being able to create a kind of decentralized spatial structures in the 60s and the 70s, right? So it had a kind of particular affinity in terms of actually creating better cities, better villages, better, more decentralized spatial organization in certain aspects of planning. In this context, it means essentially that anybody can participate in economic life, and we don't put any kind of barriers in that kind of sense. However, there is, I think, a connection between decentralization in terms of blockchain and how you might think of certain aspects of non-extractive architecture, right? So more local, more autonomous, and so on and so forth. We're going to take a look at cryptography, and I think one of the really nice papers that you should read as students of computational design is Turing's Intelligent Machinery, where he goes a step further beyond Turing machines, and he essentially developed this idea of intelligence on the computer, right? And all of the questions about could a computer think, and so on and so forth. Obviously, Turing was also a practitioner in terms of cryptanalysis. So part of the ideas that you have in physics in terms of entropy, in terms of the kind of chaotic state of information, goes into cryptography as well. So all blockchains, to be able to operate safely, use public key cryptography. This essentially is a pair of keys. One you keep private, and the other one is public. And you encrypt everything with your public key, and you can read it with your secret key. Or if it is I'm to send you a message, right? I use your public key to encrypt it, and you can read it with your secret key. And of course, you can also use this for signatures. How many of you have used digital signatures? Good, yeah. So real digital signatures, right? Not just scribbling on your iPad. So you'll see that a lot of the things we're going to do with a blockchain account involve those keys essentially. Never, ever, ever reveal your private secret key to anyone. Okay, don't do that. The kind of cryptography that is used here is called elliptic curve cryptography, and it uses very architectural actually. It uses this kind of third-degree formulas that create these elliptic curves. And essentially what you do to generate the pair of public and private keys is like a player of billiards, right? You start playing this, sending this ball around, and then it bounces off. And you do it in a set number of times, and these kind of pairs will create the keys essentially. The mathematics are fairly fascinating. I don't profess I understand fully the whole thing. So, have a look at some of the resources I'm going to show. And you can try it also on Desmos, where you get a really nice graphical representation, and you can play with the sliders and the formulas to generate your own. And is what I was talking about what cryptography has. Essentially, through using your public key, you can take some text and then generate the hash value, which is going to be of a set length. Sorry. And let's see now what we can do with it, right? What can we do with this technology? Obviously, you can record on a blockchain ledgers of cryptocurrency, right? I have 5 Bitcoin, you have 10 Bitcoin. I buy coffee for you from you, right? So I have to give you 1 Bitcoin. So we can record this transaction exactly in the same way that it will happen when you go to Starbucks and get a coffee. But instead of doing it via a card that informs the bank, what you do is you use your account and you inform the blockchain for that change. Okay. Your account is essentially only a wallet that holds public and private keys. So here we can have decentralized finance. So I can essentially take my crypto and lend it to someone, right? So I can deposit it on a smart contract. And this provides liquidity to the smart contract, and someone can take it and use it. I can create organizations, right? So I can automate organizations by using smart contracts. I hope you have not experienced a lot of bureaucracy in your life, but essentially the concept is that you could replace part of bureaucracy with smart contracts. You can create obviously fungible tokens, non-fungible tokens, which we're going to take a look at a little bit more securely. You can create excellent infrastructure for supply chain problems, and blockchain, due to its nature, can track, for example, food a lot better, food sources, but also in our case, it is a very good example for creating supply chain trackers for embodied carbon, material passports, and so on and so forth. And we're going to try and see an example like that. You can create escrow accounts that could also represent legal contracts, but also you can create games. How many of you know CryptoKitties? Only one. Do you have any? No, you haven't bought any? Okay. You could not afford it. So after today, you will create your own and you can become rich and famous. So similar kind of idea, we're going to see examples of DAOs. We're going to see examples, I mean, we're building one, right? We're going to see examples of decentralized design applications that we've done with Wassim, ideas of digital twins, and so on and so forth. So going back to a prototype we did, we started 3 years ago, I think. Then we kind of developed it into a really nice prototype. Well, this is what got me into blockchain, actually. So we designed a blockchain city with my partner, Davide Lombardi, in Ilong in Gwiju province. And back then we were not thinking to use essentially the idea of smart contracts. We were thinking we would distribute blockchain nodes all around the city, and we would use the heat generated to heat the apartments in the city, right? That was so we kind of scripted a blockchain, sorry, not everything is a blockchain, Theo. We scripted a Grasshopper script that would kind of generate this kind of layouts. We selected one and then we submitted it to the competition, and to our surprise, we got third award. And at that time, I started talking with Wassim, or Wassim did something smart actually. He asked his network for certain questions in terms of building information modeling, and I kind of responded to his questionnaire. And then we had a chat, and his idea was, well, building information modeling uses essentially a database behind the scenes, right? So when you're changing something, there's a database where you go and change an entry, right? And Wassim had a question like, how could we replace that database with a blockchain, right? And you know, is that feasible? And around the same time, we were thinking with Davide, right? Could we connect, you know, Grasshopper with the blockchain and see what we could do? Again, not going into the level of why. It was more of a kind of a research as each to say, well, could we actually do it and see what is interesting about it? So we kind of identified 4 levels, right? You can create a blockchain inside a card program. You can connect a card program through the web with a blockchain, or you could run your own ETH node, right, and connect the card program directly to the ETH node and then to the blockchain. And even more interesting, right? You could use the whole blockchain and run a whole card program on top of it, right? With every level, of course, there are constraints in what you can do. So this is something really simple as an example, right? There are many Python blockchains on GitHub, right? So you can pick one up. You can really fast edit a couple of nodes in Grasshopper, and you can run your own blockchain inside Grasshopper. It doesn't have any kind of, other than, you know, credits in terms of being able to do it. It doesn't actually do a lot in being productive. But one of the things we did is we used the Node.js, which is a web server, to connect Grasshopper with Ethereum. And we repurposed a really simple tutorial called the pet stop tutorial. And what we were able to do, excuse me, is showcase that you could actually create an optimization problem and you could actually pay someone through the blockchain to solve it and do the whole process automatically, right? And this is kind of like the idea behind that paper. And then we started working a little bit more carefully with the team in trying to essentially think of ways. So here, we're not decentralizing at all the process of actually designing something, right? The architect is working alone, they solve a problem, and we pay her as soon as she does the job, okay? But that's not the interesting part, right? The interesting part would be to try and get a whole architectural design problem and try to put it on a blockchain, right? And from that point of view, we started conceptualizing a whole structure. I mean, you might call it a DAO, but for now, we're just going to talk about computational agents. We have an web interface to the smart contract. And then you have 5 smart contracts that create an architecture that helps you essentially solve a particular problem. Behind the smart contracts, you also have the interplanetary file system. How many of you have heard of this? No? Okay, we'll introduce it later to kind of understand it. So because of the gas cost, it is very expensive to store something on the blockchain, right? So if you want to take a whole BIM model and put it on the blockchain, it's going to cost you a fortune and it's not practical. So what is practical is actually recording on the blockchain the hashes of different edits. So if you do a change, you can hash that and record that, while the BIM model remains on a decentralized storage, which is IPFS. And IPFS works with content addressable system, right? So instead of saying, where can I find the information, it works with what is the information. Okay, so if I'm looking over a picture of Theo, this gets hashed explicitly, and no matter where it is stored all over the world with the hash, I can find it. And we'll see an example, a practical example today. So this enables you essentially computationally to take a topologic model, for example, put it in IPFS, and then use the smart contracts you have on top to essentially regulate the way you solve a problem, right? So the BIM manager actually connects with the BIM platform. The IPFS hash holder connects with IPFS, and you have a problem smart contract and a solution smart contract that essentially just record numerical values. The problem we're trying to solve is an optimization problem. So this is kind of like the architecture of what we were trying to do. But I'll walk you through it so you can kind of visualize what's going on. We run a test Ethereum blockchain on our desktop, deploy a smart contract. This is what IPFS looks like as an interface. And then you have a web browser that essentially shows you, allows you to register a problem. The problem owner uploads the file that describes the problem. And this might be a Grasshopper or even a topologic file already. You see, obviously, so that's a blockchain wallet on the top with MetaMask. The smart contract then takes that file, it creates essentially a unique hash out of it, and we are ready to go and solve the problem. So a second account comes in, registers as a solution provider. And from the point of view of the blockchain, this is just an address. It doesn't mean that you have a human behind it, right? So you very well might have a mid-journey AI trying to solve that, right? If you could train it to do that. And at some point, you provide a solution. and you not only give a numerical value, but you also provide the file through IPFS. Back then, I wasn't actually coding any of it, so we had a company who developed this for us. So they developed a Grasshopper plugin that can talk to Ethereum. After that, we found much better solutions. So you solve essentially a structural optimization problem. You find a value, and even though I told you never reveal your private key to everyone, right? We'll use throwaway accounts to do this. So here you essentially take a optimized value, you sign it with your private key, and you send it to the blockchain. And as soon as that happens, the current optimized value is there, and you can get paid for it. And again, this is the first idea of decentralizing, essentially, or first prototype and concept of decentralize the process of solving an architectural problem using blockchains. And there are some implications around this, right? So the first one is, only I could get my computer to work, is that you get two scenarios. You get a collaboration scenario and a competitive scenario, right? So we can structure the whole thing. Imagine 3 designers. As soon as designer 2 does something valuable, the system can note it in their contribution, but also it can take through IPFS their files and synchronize them with everybody else. So you can share files like that. Then designer 3 contributes to advancing the solution, and that's also shared. And obviously, you can share funds between the designers, so you can reward collaboration. Or you could actually run a completely competitive scenario where only the best solution wins. As such. And the hawk-eyed amongst you might have realized, right? I was talking about an optimization problem, which is easy to conceptualize for this kind of architecture, right? Because all you need to do is find one value or a set of numerical values that are the best possible parameters for what you're trying to solve. But design problems are not like that, right? Design problems are wicked. They don't have a clear-cut solution, right? Optimization problems are already having defined, we find optimization problems when we already have defined very well what we're trying to do. So we went a little bit further. Just skip this because it's just on the infrastructure part, right? So a way to kind of create closer the idea of running a BIM model on IPFS, and then the smart contract records all of the deltas and the changes on the model, and you can reward people who participate in the system. This is what a smart contract looks like on a very simple basis. This one records the string and a uint. Just go to the DAO to discuss this. So we kind of created the idea that a group would actually use smart contracts to kind of vote on solutions. So a couple of other papers we wrote were on setting up an organization where you propose a solution to a design problem. Again, solution in quotation marks. In this aspect, it was tape grammars that were producing layouts for towers in the city of Suzhou in China. And we were selecting kind of like the best solutions in terms of solar incidents that would pass through the local regulations. And the idea here is that you have mature designers and much more junior designers, and they're all using a voting system to select which solution out of all of the variations of the tape grammar to advance next. So here you have the indication of a human essentially intervening. Another prototype that was, I think, for me, one of the most fascinating ones. Using essentially non-fungible tokens was a really good combination of what topologic can do and non-fungible tokens, right? So I don't need to introduce topologic to you, right? You have the Wassim right here. So we kind of took the concept of this, non-manifold topology, but also the idea of graphs, of dual graphs that you have spaces connected with each other, but also each space can understand or can recognize walls, windows, and everything else. And you can break down a building into the set of spaces that you have into the rooms, and obviously every room will also have structural components and so on and so forth, right? And as soon as you break that down, you can also connect it then with a chain and create tokens out of each room and its component, right? And this is what we did here with a very smart kind of idea that the theme had of bypassing dynamos built in Python and using the system of the Python system, the system Python, sorry. And what we're doing here is taking a set of 3x3x3 spaces built really easily in TopoloGic, and then taking this whole tree and making a non-fungible token out of it, right? So you can essentially have a really simple representation of a building onto a blockchain. You might say now, okay, so what, right? First of all, you can have the idea of ownership attached onto a computational protocol, right? So someone can own that NFT, and essentially that representation acts as a digital twin of the real building. Okay, but much more importantly, we did it with, first of all, the full graph. But what happens if I start? We'll see how the contract works. What happens if I break it down into components, right? And I create an NFT registry that has essentially all of the building materials or all of the components, right? So imagine a tree, a data tree that has at its root the building itself, and then through TopoloGic you analyze it to its constituent components, and you put all of those components on a smart contract. First of all, you create an immutable database of the materials that are contained in the building. If you want to recycle it 50 years from now, you have the files there. You don't have to go to the console. You don't have to scan paper drawings, right? Nothing like that. Also, any kind of changes to the building can keep on, you can keep on recording all of the changes there. And from that point of view, you have a kind of, again, persistent record. You have a log of what takes place in the building. And you create a kind of immutable cadastre of all of the materials that exist in the building. This is kind of a conceptualization, an abstraction of how we did it, right? It almost doesn't matter with TopoloGic. It doesn't matter what you're running it on, as long as you have TopoloGic and Python, then we can mint it on a smart contract, right? And this is how we're gonna talk to it essentially. Through visual programming in Python, you create first the IPFS, and then you give it a number on to the Ethereum smart contract, and there you have it. You have your NFT, and this is showcasing it here through Blender. Shall we take a 5-minute break? Yeah. Yeah, it's a good stopping point because these were all projects we did, and now I'm going to introduce you to a couple of other abstractions, but then we'll jump right in. I see some of you are getting frisky in terms of going hands-on. So 5-minute break, and then we'll do 10 minutes more of presentation, but then we'll go into code. Are we back with the recording? Okay. Okay. So not long to go. Do you have any questions so far? Okay. So the way mining works is that so this goes back to consensus algorithms essentially. For Bitcoin to actually verify a block, the Bitcoin chain, you need to essentially do the work, right? So you need to do the cryptographic work of generating that number. And by design, the protocol of Bitcoin made it, I think they have a half time of 2.5 years. Then every 2.5 years, the difficulty becomes, no, sorry. The difficulty becomes bigger, not every 2.5 years, but the more computers participate on the network, the more difficult it becomes to mine a block, because the pre-selected target becomes much more difficult to find. So what happened is, initially, when Bitcoin started, you could run it on a laptop. You could run a miner on a laptop because it was very easy to mine Bitcoin. Now, trouble was, in 2009, nobody thought people are going to make money out of it. Like, you had people buying a pizza with 100 Bitcoin, right? It was only people who were really curious and kind of really delved into the idea that we can have a separate economic system that is based on computation, because that's exactly what a blockchain is. It's a separate economic system, a peer-to-peer economic system that bypasses the bank. Now, if you're a bank, you might think in 2009, this will never work out, right? 2022, though, they kind of think that they have taken it seriously, and you'll see that central banks want to create what is called central digital currencies, which is essentially a blockchain controlled by central banks of countries. Okay, which means that all of your transactions are completely transparent to who owns blockchain, which I think is very dangerous. Okay, now the proof of work algorithm is also the main criticism point for blockchains, because it makes it massively energy inefficient, right? You have all of these computers trying to compute numbers, right? The solution to that is switching from a proof of work to a proof of stake, which means that nodes participating on the network to gain a cryptocurrency take a fixed amount of cryptocurrency, and the incentive works the other way around. Not only you gain, and every kind of 7 seconds, one new node is selected to mine the next block, right? In a kind of random manner. If you are selected, then you gain currency. But if you try to cheat, you get your stake slashed. So there is a disincentive for the nodes that are going to try and confuse the network. Okay. Now, most of you will not operate on that level, will not operate on the level of micromanaging a node, right? Most of you as AEC professionals will basically work with smart contract, which is essentially trying to understand whether you need a smart contract, right? And can you assign some values to it? Okay. Did I came close to answering somehow? Okay. Any other question, please? Yep. Yes. So the first, so correct, right? So the solution we have kind of created in terms of decentralized and optimization problem is exactly what I was trying to say in terms of saying most of the day-to-day design solutions are not optimization problems. We did this because as researchers, we wanted to kind of make a point and prove feasibility. We've proven feasibility, but let's now go and see how do you actually use it. And this is where the idea of voting in a DAO comes from, where you basically say, well, I can essentially create a smart contract that regulates a design team and the regulation, the governance comes from voting, right? When we were doing this, we were thinking, okay, but should my vote, is it democratic, right? So you have the classic democracy versus technocracy kind of idea, right? So I'll take Wassim, for example, right? His really experience in computation and in architecture, right? So should his vote count as equal as someone who just entered architecture school? Most people would say probably not, right? So his vote could be weighted, right? But at the same time, you should not exclude original ideas by junior members of staff, let's say, right? So their proposals should also have a chance, but maybe they're not, their voting power is not as great. So you can create these kind of systems that are your own mix between democracy and technocracy, depending on if you have too much democracy, you might end up with populism, right? You might elect a design solution which is favorable to most, but is actually really poor. Or you might select a really good design solution that is only likable by me and Wassim because we're old and experienced, but nobody else likes it, right? And this is a very hard solution to a very hard problem to address anyway. And you have to go back to participatory design if you heard of processes like that, where you can create essentially a DAO where the stakeholders of the design also participate. So you could have, for example, people budgeting for whether to create a hospital or a public park. And then after they budget, they would actually vote on it, right? And we'll see this, an example of a competition we did on that. The system we designed, so far I've designed 2 DAOs. One, you'll see also how ArchiDAO works, where it's more democratic. So on this system, there was a weight depending on your experience and whether your solution was close to optimizing the problem. There was a combination of, but it doesn't mean that you cannot lose a vote, right? So you could actually be very experienced, but then also lose the vote. Does that make sense? Mm-hmm. Yes. 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 So depending on what kind of organization you are building, you need to select the proper governance mechanism and the proper kind of democratic mechanism. When we will talk about ArchiDAO, you will see that we very much elected to have a mechanism where one member gets one vote for running the organization, but then in each project, you have a decentralized kind of idea where the people running the project decide. And we very definitely did this because when we were presenting in ICADI the ArchiDAO governance system, a very experienced member of staff of ICADI had a question and said, so what if Elon Musk buys you out? Because if you base it only on owning part of the token, what you get is you can get essentially rich people deciding where to get an organization. But ArchiDAO, we'll see, is an architecture, it's a scientific organization. So we need to create a protocol that guards against someone coming in and saying, okay, I see something of value, I'll buy you out. And then, I can, as we see now with Twitter, I can do whatever I want with you. Does that make sense? So I'm not advocating for one, it's exactly as Wassim said, it's depending on what you want to do or what is desirable, you can kind of design and experiment with decision-making approaches that favor technocracy or favor democracy or a combination depending on what you want to do. Any other questions? Go on. The incentive is that you get paid. Yeah. Yeah. So there is one of the earlier mechanisms that we used here was called DAO stack. And they had a similar mechanism for this, which was not getting a higher vote later, right? which is also can be capped because that can also create power imbalances. But they would reward you if you guessed right or how the vote would go. So, and this was a mechanism to signal out of, say, so democracy is hard if you actually try to do it every day, right? So if you have an organization that has 200 votes every day, right? Imagine if you need to vote, you need to come in, get informed what is going on, then vote, right? Which one of these can we just all agree that we go with consensus, and which one actually requires a vote? So in DAO language, you'll hear, for example, a DAO called Colony that already says that if you need to vote, that's already adversarial because it means you have a disagreement, right? And you'll see that a lot of design decisions in a design office, they don't go out on a voting kind of scheme, but there is consensus, right? Or you have experienced members of staff at some point pulling rank and saying, we'll do this, right? But a lot of times you'll see that design teams work in a kind of consensus kind of idea. So from that point of view, you don't want to create overly complex schemes. And what you're trying to do with the token is shift the attention out of the 200 votes to the 5 that are most important. So people essentially would, so in DAO Stack, you had a betting system to say, put your stake to the one vote that you think, to the one proposal that you think is more important for us to consider, or to the most adversarial one. And all others would pass with consensus, and the ones that were kind of controversial would go at the front of the queue and would be decided upon. So you get systems like that, either very, very consensus achieving, or very smart in terms of sifting through a very, very many decisions in terms of that. So I'll try to present 2 more projects, and then we will go and look at our tooling. So we'll set up our environment, and happy as we're doing that to also answer questions. You all probably know we had a pandemic for 2 years, which meant that you could sit around your house and not being called antisocial if you did lots of writing. So at some point we thought maybe it's a good idea to have some kind of, we went into a couple of workshops. I hosted one virtually in Robert Gordon University in Aberdeen. And we kind of made a call for papers to look at applications for blockchain for construction. And this is the result, a book that came out in September as an ebook. And the last chapter is called Collective Digital Factories for Buildings and Technology Collaboration through Cryptoeconomics. And it describes the theoretical model of what I'd like now to build, or I'm trying to build now with Wassim and Davide and a couple of others. Sorry, I have my screen on, my back to the screen. Is it going to work? Yep. So let's see, taking this whole idea, I mean, I promised you that we're looking at a new political economy for architecture, right? What does that mean on practical terms? So this is the cycle of a project that starts with funds. And to be able to be part of the design team, you need to stake your token. It gets created for that purpose. And you get a token, a governance token back. And that governance token gives you a seat at the table. Right? It gives you voting rights or decision-making rights. And then those part of the design team, and again, it might be a mid-journey AI or any kind of AI, or it might also be a human or a group of humans. Use TopoloGic to generate a series of models, a beam model, an energy model, and a waste and circular model. The waste and circular model uses the NFT mechanism we saw before. And in classic fashion, through consensus, you go through iterations of these, and you try to optimize for building performance, productivity increase, right? So the most efficient way possible to build the building by using the model. And you also try to reduce waste, and you try to reduce carbon impact. And this might be by careful choice of materials or careful choice of construction method. And in any case, what we describe is a way to record those changes, how the stake pool would work. And as soon as you reach an efficient state, you get essentially paid back, and the funds which you have a stake on increase. And the idea here is to try and create decentralized finance mechanisms and mechanisms of tokenization that shift part of the value of what we're doing in the built environment, not only from value that gets captured from traditional contracts, but also to certain values that have an impact on the environment and the wider kind of society that the building operates in. And the idea there is that if you try to, at the moment, we're trying to solve the carbon problem with policy. Doesn't work. Doesn't work if you have certain government and if you have certain industries operating in the way they do. You might want to do it with restrictions or regulations. Again, it takes about 10 years from the moment you introduce a restriction or a regulation until it actually has any effect. And actually, a lot of the time, we might want to sift the idea of extractive architecture, of having value to something that is a little bit more circular. And this kind of mechanism would reinforce that by placing a value to waste, carbon incentives, and building performance. And the other thing that this introduces is that the idea that you can have machines and humans operating together, not only creating a building, but also helping the public good, and while at the same time having a financial incentive to do so. It's kind of funny to talk about all of this. We wanted to start a DAO very early on, 4 years ago, but back then it was still crazy. But we managed to start one in December of last year. So if you go to archidao.io, you'll find a website there. Currently, we're building prototypes so that we can get essentially ArchiDAO working. And what is ArchiDAO essentially, right? It's an architecture office and an architecture team operating on smart contract, right? Using the blockchain essentially to work together. We wanted, and we based essentially the decision-making approaches of what we will encode on the smart contract. We do a lot of research, and we discuss it between us to be able to kind of choose the best system possible, because the moment we write it on the smart contract, right, this is going to have implications for the organization. So we took a look at, I'm guessing you all know CUMINCAD, right, the cumulative index of papers in computer-aided design. And we looked at papers that discuss collective authorship, right, so collaboration and so on and so forth. And we found essentially, we kind of ranked them according to 8 principles, ranging from communication between members to how decentralized the system is, and is there the idea of a substrate, right, a medium that enables collaboration. And from that point of view, you'll see that in all of the research we found on CUMINCAD, there are, the principle of communication between members exists, between members and the design object. There is the idea of feedback loops, remote collaboration, but there is very little in terms of decentralization and very little in terms of sigmergic collaboration, the idea of a substrate. Another idea that we are trying to work with is the one called the viable system models that comes from cybernetics. You might have seen a really sci-fi image of a cybersyn room in Chile, right before Allende got overthrown by the dictatorship, where they were trying to build a kind of dashboard of the whole production of the Chilean economy, right? And the idea of the viable system model is that you build this kind of decentralized teams that can make decisions for their local condition, while at the same time being cohesive for the whole organization, right? How do you set that up? And a lot of times this works very closely to kind of system of decentralized command, that you don't get a hierarchical top-down structure, but you get more of a bottom-up idea of collaboration. So the viable system model was created by Stanford Bear, who is a kind of scientist, not a kind of, he was a scientist of management, and she created the CyberSyn Chilean model, but also she created a lot of other models in terms of organization structures. But what we're trying to build essentially in ArchiDAO is closer to stigmergy, the way you know it from ant colonies, for example, or bee hives, where the actual construction medium acts as the medium of collaboration. Yeah? And within that, we try to encase incentives, trust, and the idea of common pool resources, where the resources you manage for a project are not just yours, but actually they have a lot more to account for outside that. And at the center of it is an NFT, a non-fungible token that belongs to each agent of the organization, whether that agent is a machine learning algorithm or a human. And that NFT provides you with governance right? So at the moment, our current discussion is that one NFT equals one vote. And then there is a second token, which acts as a token for stating and governing projects that has also economic value, right? So you have two token structure. One provides you a seat at the table, so you're a member of ArchiDAO. And the other token provides you with the ability to do project. Another project we looked into was how do you structure smart contracts for digital twin. I won't go too much into it because I think I will lose your attention, but there is a paper on ASCAD that describes it, on how you can use smart contracts and IPFS as the infrastructure for a digital twin, and you can also make decisions for it. And we recently did a collaboration as ArchiDAO with No One's One, where we built. So No One's One is a DAO in Switzerland that have created a space. They call it a space that belongs to no one, and it's a meditation space that operates through smart contract. Okay, so we built the digital metaverse version of it, and you have a two-way communication between the physical space and the virtual space in Decentraland, and the tokens you use for the physical space can also operate on the digital space and vice versa. So we're trying to build this. Closer to visualizing this as architecture, we recently did a competition, participated in a competition in Sofia, Bulgaria. Was created by the municipality of Sofia, and they wanted essentially a connection on the south park of Sofia between the north part and the south part of the park. We kind of created a network of nodes that you can see on the top left as you're watching this, and through that mesh there is a kind of spine emerging that picks up all of the pedestrian and cycling functions. And on the nodes of the mesh, we also create these kind of follies, which were created with kind of pieces and particles in Blender. But the idea we introduce here is that you can break down the bridge into components that are represented by tokens, and you can fund, you can both fund the bridge and engage the public by having the public own part of the bridge, right? So you, each citizen could actually pick up a token and pay for it, and through that you kind of raise the funding for creating the bridge. But also there are many mechanisms of how you could kind of take the bridge and discretize it, right? Whether these are the boards on the floor of the bridge or designed for the balustrade and so on and so forth. And how do you create essentially components that can be represented by tokens, which is totally architectural. And then through that, at least our concept would go that people who would actually pay for a token could actually then decide, what color to make it, how big it would be, but also they could pay for maintaining part of that public infrastructure. We didn't win anything, but my career has shown you keep on failing until you succeed. So hopefully we'll do some more of these projects. And I'll kind of exit, and then we'll go back to questions and discussing more of code in that sense. So any more questions? No? Okay. So how many of you have a MetaMask account? One. Only one here wants to be written famous. Well, the same as well. Okay, so we will create your first entry to the blockchain. And the first thing you need to talk to a blockchain is an account, right? Do you all have either Chrome or Brave browser? So this is the hands-on part. If you want, right? You can also ask questions or. So what we'll do today is set you up so you can talk to a blockchain. And then I'll show you 2 or 3 things you need to have set up, plus a repository which I'll keep on updating that where you're going to find interesting stuff on. So if you go to metamask.io, right, sorry. Sorry, yeah. Sorry about that. I thought I was sharing that, but I was sharing just the. Is it okay? Yep. If you go to metamask.io, so first advice, the account you create today, because you're on a public network and everybody can see each other's seed phrase, don't use it for anything else other than testing. Don't use it with real crypto later on, okay? Because it's unsafe, okay? If you had, it's not safe if you hotspot, no. So do it through a network. So when you create an account you're going to use with real crypto, do it in a network you trust and when you're alone. Does that make sense? If you use a public network, use a VPN. Okay. So if you're on public Wi-Fi, don't trust it. Actually, the university is probably your university Wi-Fi is much more secure than anything out there. Yeah. So download this for Chrome. And then you're going to go through a process of creating a seed phrase and setting up a password. And you're going to get this nice little looking fox on the top. Another way to enter the world of blockchain is to use the Brave browser, which actually pays you to look at advertising. And Brave is a fork of Chrome, because you get this exact same functionality. You want Wassim? Okay, yeah. Yeah. Okay. Anybody needs any help with MetaMask? Again, I'm not going to warn you with the account that you're actually going to use to earn a fortune later on. Keep the seed phrase secret. Okay. And as soon as you have MetaMask set up, we'll go and we will generate our first contract, and then we'll deploy it on a test network. So we're going to see this cycle today. That's a simple idea. And then tomorrow we will kind of brainstorm for ideas, and we'll build a much more custom or custom kind of smart contract and set up your environment. Okay. So to be able to create a smart contract, we will be writing in a language called Solidity, which is specifically designed for Ethereum. Having run those workshops before, we have created a really nice web page, which is having a lot of links that can help you develop. So I'll share this with you. From setting up a development environment to reaching the level where you have blockchain basics, Ethereum primitives, and much more closer to writing code, right? Solidity fundamentals. And the smart contracts are half, kind of like the half the project. You also need to talk to a smart contract, which means you need to talk to blockchain, right? So how many of you are running blockchain nodes at home? No one, right? So you need to find, I will certainly not share my blockchain node. So you need to find a public node to do that. And the way to do that is by going to infura.io and creating an account there. So Infura is the public service, and actually your MetaMask is also a wallet that connects you to a blockchain node. Okay. The more secure manner of connecting to a blockchain is running a node at home, but that means you need a dedicated computer for that. It will need a lot of hard disk space, and it's going to cost you something like £1,000 to do that. So unless you are very, very, very serious with it, you know, MetaMask and Infura are the way to go. So after we create an account in Infura, you can still see my screen, yeah? Okay. You might get a deprecation notice that with the merge having occurred, it means that certain older test networks that were running a proof of work algorithm, as we were seeing, are now no longer active. Yes, I'm all set. Don't worry about it. So we have I've created a project called DBIM, decentralized BIM. And you'll see that I have an API key, okay? Don't worry about that yet, but I'm just showing you what we're going to use tomorrow, yeah? But also, I have the option of using mainnet. So this is the actual Ethereum blockchain. Or use something called Gurley or Sepolia. So these are test networks, right? Because you have the problem, right? Everything in the real blockchain costs money. If you make a mistake, it's going to cost you, I don't know, some dollars. There was a case at some point we were running our prototype with Wassim back and forth on the real one, and it, if we continued, it would actually arrive at an unsustainable condition. So all of our work will either happen in blockchain that we will spin out on our desktop, right, or on a test network. Did you all manage to set up your MetaMask? Yes. Yeah, engineer developer. Yes, solo freelance. That's fine. Yeah. Yeah. So if you have if you have MetaMask set up and Infura set up, we'll go and create something simple first. We'll go and create a non-fungible token. And easiest way to do that is if you go to this address. That's the easiest way to share things with everybody. Yep. Well, I'll do this. Where was the? If you go to this address, github.com/rlove, that's my account, and then Cardiff _2022. Yep. Okay. Yep. Yep. That's fine. Yep. Yep. Set up. Yep. Okay. Yep. Okay. Almost everybody. Good. Go through the motion. No, 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 no. You don't have to. It's public. You don't need a. Is it public? No, Cardiff 2022.
2020.
Sorry. Yeah. You go. Yep. There you go. Okay.